hardware implementation of a neuron. In this session we will see how can we implement a simple neuron using hardware. So as we can see in this picture, this is a model of our simple neuron where we have inputs from x1, x2 to xn, and each input has a specific weight. W1, W2, Wn are showing our weight. All of them are going to some signal with B, which is for our bias, and the bias will say our system how strict is it. After that, our net signal is going to activation function. This is where the magic will happen, and finally we can have our output. So let's take a look at this model. Here we have our inputs. Let's call them x1, here x2, and then through xn. Each of them has a specific weight. We are showing the weight with a resistor. These are our resistors. W1, W2, or R1, R2 to R of n, which are our resistors. And finally, we will just feed them to an op amp. Here we have our op amp. This op amp will act as our activation function. So this is our F function. And then F of net, of course. And then here, as a bias, just look at this model, as a bias, we will just connect it to the battery. And then we can just adjust the voltage of a battery to have a bias that we are looking for. And finally, this system will give us an output of a Z. You can simply design your neural network using different softwares, and then if you want to implement it using hardware, so you can just use this model. There are several advantages of using an analog system compared to the digital system. One of them would be analog systems are much more faster than digital systems, so they can respond very faster. But of course there are some limitations for analog systems. They are not extensible, and we can just use them for specific purposes.